Hello, this is Shenming Zhang, and this is the presentation of Calculus 1. And in this presentation, we'll basically talk about the cost, revenue, and profit function. And then we'll explain the how Washer method works. And then we'll talk about the moment and the center of the mass. So first, let's talk about the cost functions. So basically, they are total cost function, average cost function, and marginal cost function. And for total cost function, they are Q about the per unit we sold out, and C is about total cost. And then C equals to F, which means the fixed cost and it's constant, and the variable cost, which will change parallel to Q. And they are average cost functions. That means the average cost of the per yard. Then marginal cost function is the derivatives of the total cost function, which means the value increasing about the cost when you add single yard. Let's get to an example. A company has sold out 1,000 units of product this month, and each cost of the unit is 50 ringgit, and the price per unit is 80 ringgit, and the monthly rent of the company is 500 ringgit. So first, to find the total cost and average cost of this month, and increasing the cost when you add and find the increasing of the cost when you add per sold unit. So let me analyze this. So for the total cost, they are fixed costs and variable cost. So they are obviously the fixed cost is the monthly rent, which is 500 ringgit, and the variable cost is 15 ringgit, which is linearly to the amount of the unit we sold out. So the total cost is 500 at 50 multiply 1,000 equals to 50,000 at 500. And for the average cost, it's simply just the total cost divided by the amount of the unit, which equals to 50.5 ringgit. And for the marginal cost is the derivatives of the total cost, which we can derive this by this, and we have an answer of 50 ringgit. Next, let's talk about revenue function. So the total revenue function is the price multiplied the amount of our product. And average revenue function is the total revenue divided by the amount, which simply mostly equals to the price. Let's get to an example. So it's still the circumstance, and the price is 80 ringgit, and the amount is 1,000 ringgit. So the revenue is the amount, the price multiplied the amount. So that equals to 80 multiplied 1,000, which equals to 18,000. And average revenue is the total revenue divided by the amount equals to AT, which is the same as its price. And then profit function. So total profit function is formed by the revenue multiply the total revenue substance its the total revenue minus the total cost. And the average profit function is the total profit divided by its total amount. And let's get to the example. And before we find the total revenue and the total cost, then we can just minus it. And we got 29,500, which is the total profit. And we divide it by 1,000, and we get 25.5, which is the average profit. And next, for the washer method, I think it's just about to integrate it and form the space of this ring or this circle. Like if the R of the circle or the ring is about y-axis, and the rotation of the axis is x-axis, then we can just integral it by the x-axis. And for the Dix method, it's just simply integral, but for the substance of two function, we just used washer method. So the function is just about it's like two Dix methods, they minus each other. So we use the Dix method for fx, and then for the minus the Dix method for the gx. Then we get the volume of the solid. And to simplify the equation, and we get pi integral a to b fx squared minus gx squared dx. So for the example, they asked me to find the volume of the solid generated by the revolving of the region bounded by the parabola y equals to x squared, and y squared equals to 8x about the x-axis. So the rotation is about x-axis. Then if the rings or the circles, they r is about y-axis, then we can just integral it by the x-axis. So let's get the function. So as we can see on the graph, the y2's volume is bigger than y1's volume. So we can set the vol it's basically y2 minus y1. And the r of R2 is just its volume, just y2, and the r of this curve is y1. So the function is pi integral y2 squared minus y1 squared dx. And then we can just simply integral it, and we get 48 pi over 5. Then for the moment and the center of the mass. So first we gotta know the moment of the object. So for the line, if just line, then we get the mass of this point multiplied by d1 equals to the mass of this point equals to multiply d2. So m1 d1 minus m2 d2 equals to 0. Then if we just suppose this point is this x, and we can just explain the distance. So m1 equals to x minus x1 minus m2 x2 minus x equals to 0. Then we can simplify this. Center of x is equals to m1 x1 add m2 x2 over m1 and m2. Then if we gonna generally to find the moment of center and the center of the mass, so we can use the function of the general circumstance. So the density is mass over area. We can use that to find the center of x and y. So the moment amount is about this function. And then we're gonna use the integrals, of course. Then for the integrals form, so let me explain the amount of each axis. So for the y-axis, we can the function is like, so for the moment of y-axis, the function is like the position of the y-axis multiply the mass of this position. Then we're gonna use the density to explain the mass. So that's like the density multiply area. So for the y-axis, the area of the mass is just the line. It's the rectangle at the first time, but we gonna use integrals. So the length of this rectangle it's like merely the line. So the area is basically fx. Then the position of the x is just x. So we find this function. And for the y position, we're gonna use the center of this area as the position. So it's fx over 2 as the position. And like above, we just multiply then fx as its area, and we get the position of y. Then the mass of the total mass, we still use the density. Then we use the total of amount minus the total of mass, then we get the position of the center. It's like the 1 over a, the integral x fx dx, and y is 1 over a integral 1 over 2 fx squared dx, where the a, which is the area, and integral fx dx. So let's get to the example. Find the centroid of the region bounded by the curves y equals to cosine, y equals to 0, and x equals to 0, and x equals to x over 2. It's like this region. And let's get what is A. So the A is the total area about this curve, about this circumstance. The integrals of cosine from 0 to pi over 2, so it's like 1. The center of y, so get into the function, is 1 over 2 cosine square x, which we transform into cosine 2x at 1 over 2 to find the integrals. Then we get pi over 8. So, and for the x of the center of x, it's like the function, and we get pi over 2 minus 1. So the center is pi over 2 minus 1 dot pi over 8. And thanks for listening, and this is my presentation.